Hi, everyone, and welcome to this week's edition of Water Talks. My name is Ryan Brown, and I have with me today Jessica Jeffries. I am if you want to go to the next slide. Yeah, I am a systems engineer here with Innovyze. I've done a lot of these, so excited to talk with Jess today. If you want to introduce yourself, Jess.
Sure, thanks, Ryan. I'm Jessica Jeffries, and I'm one of the product managers here at Innovyze. I look after our drainage design products, so excited to talk to you today about some of the challenges you might be having and some of the solutions we have too.
Yep. So if you have not been to one of these things before, it's a pretty simple concept. We're going to kind of talk through some things about drainage design and InfoDrainage today and how it can kind of streamline your workflows and processes. If you have a question at any point through the presentation, please feel free to put it in the questions box. Only me and Jess will see it, so feel free to ask any and everything. It's also a good point to highlight our upcoming water talks. We'll be discussing the differences between the InfoWorks ICM native sim engine along with the compared to the swim engine and how exactly those compare and how they're different. And that should be a really good topic, especially for people either new to ICM or looking into it. So I guess with that, I'll let Jess kick it off.
Thank you, Ryan. So I wanted to start with a bit of why are we here? Where does drainage design fit? And what we find the world over is regardless of the regulatory requirements and regulatory environment within which you're working, drainage design is part of gaining approval or consent for land development. So it's a pretty important part of that process. However, it tends to come at the end. So often the site is already defined, the drainage has to fit in, and increasingly we're seeing more and more constraints around delivering that, and that can mean that the project costs can rise. So any delays to construction, any chance of it not being right first time can really cause a risk to consultant engineers' margins. So what we want to do with our drainage design solution is help to address some of those issues, help to improve some of the efficiencies you have in your drainage design processes. So these are typically the challenges we hear about drainage design. People are using different packages to complete that design, and they need to keep track of what's going on in different aspects of the design across multiple packages. So that might mean surface data in one package, the pipe and manhole design in another, green infrastructure often being designed in isolation. And whenever we have to recreate that design data, there's time. That's quite a time-consuming process, but also there's a risk of error being introduced. Wherever we are, we need to demonstrate compliance to local standards, and those can vary quite significantly depending what region within which you're working. So it can be a challenge to make sure that what's being produced from the drainage output actually meets the local requirements. And we're seeing, particularly with the increase in green infrastructure, a wider range of non-technical stakeholders. So people that are maybe not familiar with a hydraulic model, hydraulic modeling terms, and it can be more difficult to express what's being represented with a complex low impact development green infrastructure approach in terms of the vegetation and the filtration to those non-technical stakeholders when it comes to the drainage design. So we want to try and improve the efficiency around that those drainage design projects can be delivered and address some of those challenges. So as we've said, drainage design is often on the critical path, tight timelines towards the end of the process. All the client wants is to get the approval, the consent, so that construction can start. Where those multiple different data sources exist as well to adopt, we want to support all of those and help move away from a suboptimal process where you can be working across multiple different packages. Also allow engineers to combine and design the traditional and green infrastructure elements in a single software solution. And this is where we can really help to optimize the process and improve the efficiency. So some of those challenges, too many tools, data coming in from different areas, having to rework designs sometimes, and also finding that drainage calculations that happen and that are demonstrated don't actually look like what's going to be built are some of the things that we've addressed with our solution. So we have a dedicated graphical drainage design platform, and the graphical element really helps to demonstrate what is going on in the design, particularly when we're looking at green infrastructure, we're looking at above ground solutions. Actually being able to see on the site plan how much space they take up can be really powerful in communicating that design. Being able to bring in data from multiple sources, actually work through right from the early stages, conceptual design, to the detailed design level, and work in a way that allows you to meet whichever local standard you're working with by saving a template that can be reused again and again to streamline that workflow. And all of that is around enabling your projects to be delivered reliably in an efficient way with one solution. So before we get into the software, I wanted to talk a little bit more about the green infrastructure side of the solution. Almost everywhere we see climate change happening, we see increasing amounts of land development, all putting additional pressure on our stormwater solutions. With green infrastructure, the drainage can actually be more than just drainage. It can actually help to demonstrate that stormwater can be an asset. Whether we call it green infrastructure or low impact development, best management practices, if we take this type of approach where we treat the water at its source to try and slow down the runoff and better replicate natural processes that are taking place, we can often see a better drainage solution. We can improve the quality of the water entering stormwater systems. So that's often with vegetation, with filtration through soil media, where we have those green devices, vegetated devices. There's actually the potential to increase biodiversity as well. So not just deliver a drainage solution, but actually help to improve the health of the ecosystem as well. And then actually starting to think about the drainage solution as also providing some amenity value. There's a desire across the world to have an increased amount of access to green space and even blue space as well. Water and so on helps people in terms of long-term health benefits, physical and mental. So this type of approach can help to deliver communities that people actually want to live in. So as a result of these benefits, we see green infrastructure being part of delivering requirements of the Clean Water Act, being part of MS4 permits and other regulatory frameworks as well. And InfoDrainage really has green infrastructure at its heart. So you'll see as Ryan goes through a demonstration, focusing today on the efficiency part of the drainage design workflow, but that it's possible to optimize the design and gain that approval quicker than before, because we have the ability to define these structures true to site and demonstrate how we're making the best use of the space, how the green infrastructure contributes to the overall quality of the community that's delivered. But the fact we can include the traditional elements as well means we've got one system to analyze and optimize the whole design, rather than looking at individual structures in isolation and potentially missing how they behave when they're connected up to each other. At the end, you'll be able to see not only visually what the design looks like, but also some of the ways in which it can be communicated to other packages to help the other stakeholders involved. Yeah. See actually how it links with some of the other products. So over to you, Ryan, for the live demo.
I'm struggling today.
I think you got the wrong screen up there.
I sure do. How do I? Oh, there we go. All right. So you see the InfoDrainage? No.
Yep.
Okay, perfect. Sorry about that, everyone. So yeah, like that was a great intro. But so this is the interface. I just pulled up an instance of InfoDrainage that I have. So there's nothing really in here. We have this initial phase going on. Well, I guess I should start off. Yeah, I'm gonna basically go through laying out a simple drainage system for a proposed development, and just using some of the tools and things like that inside of InfoDrainage to be able to really streamline that process and get it from in the model into a set of CAD plans very, very quickly. So starting off, I'm just going to rename our this phase existing to demonstrate that it's our existing plan. I will admit there's a little bit of TV magic going on here, where I've already got a lot of libraries and things set up, but at the same time, I think those types of workflows and things like that, depending on you know, how many regions you work in, you can set up very similar workflows for your situation. So I'm going to bring in this stormwater development plan. You can see up at the top, we're going to get a little preview of what exactly we're bringing in, along with all the different layers that we that are associated with that CAD file. So if I hit finish, that comes in. I'm also going to add in a background image that's going to sit on our near our site too, just to give us a little better context of what exactly we're doing. And then lastly, I'm going to bring in a surface that's going to help us guide our design and populate some of the parameters and things like that. There's a variety of different types of surfaces that you can bring in. I've already got one set up that's in the InfoDrainage file type. So I hit OK there. And if I turn it on real quickly, we'll see the extents of where exactly that covers. If we zoom in here, I'm going to turn off the surface just so we don't see it, but you can see where our proposed development is going to be right here, where the background image doesn't show any development there yet. So I'm going to start off by turning off most of my layers and just turning on the this block body to see the outline of our parcels. First thing I'm going to do is create that existing condition to know what kinds of flows we need to match in our proposed condition. And it's as simple as dragging it on and then turning on the snap and being able to draw that out. And so that's done. And all these different functions and things like that are actually set up as object templates. You can add as many as you want depending on the, what exactly you're working on. But like the area gets filled, of course, from how I drew the shape. But these percentage impervious and in times of concentration things can be pre-populated by building out templates and things like that. There's also calculators and things like that, so you can use like TR55 methods to be able to build that time of concentration pretty easily, as well as basically lookup tables for the pervious curve number instead of having to go look in a book or something like that. So we're going to hit OK there. Really the last thing that we need to do before getting our existing condition flows is to add in a rainfall amount. I've got a library already set up here for this region that I'm working in. So you can see we now have some SES storms in there. And from there, I just go into the analysis, set my analysis criteria to use those SES storms I just brought in. I'm going to hit OK and then run the model. So you can see these are our results. Starts off with the 1 inch. I'm going to look at the 10-year because that's what we're going to be designing to. So we want to make sure that we're able to mitigate the flows so that our proposed condition is limited to about 1.8 CFS. And then just to get kind of a framework for maybe what we need to size our overflow weirs and things like that for, our 100 years 3.4, just to give us kind of a framework of what exactly we'll need to convey. So going to the proposed condition, I just need to duplicate the phase, which copies everything over into a new kind of scenario. And then I'm going to rename it developed so that we're now working in the developed condition. I also need to, because if you couldn't tell, there's basically two different areas, and what I'm going to end up doing is this top area is going to go to a bioretention cell roughly there, and then a dry detention pond down at the bottom. So I'm going to split this up into two new developed templates, so I can just change the template and change the name to match to a developed condition. And then I'll also need to redraw the outline so that it's just encompassing this top area. I'll also need to bring in one more catchment for the lower portion here. And there we have it. Whoops. Need to readjust that so we cover everything. So again, these are templates. You can see the percent impervious has changed and the time of concentration has changed for this developed condition, and this composite curve number is now much, much higher than it was before. The first thing that we really want to do is run this deluge option, which essentially is dropping a couple inches of water over the surface all at the same time, and then letting it kind of drain out a little bit so you can get an idea of where exactly flows are ending up and going into. And so you can use that as a guide for where you want to maybe lay out your system to be able to minimize grading and things like that. So we're going to run that, and if I turn on the depths, you can see some of the results down here at the bottom as far as depth and hazard values. But throughout this middle, this green area is representing higher depths where the blue area isn't. The hazard areas also kind of help give you a framework, and generally things seem to be flowing down into this middle area, starting here and then down through the bottom. So that's where I'm going to start my bioretention cell, and then use a pipe network to get down to a dry basin to mitigate the main part of the peak flow.
Brian,
So
before you
yeah,
start that next bit, there was a question came in about modeling multiple subcatchments. So does it drain from one subcatchment to another, or is rain distributed across the entire area? I was thinking maybe that needed a bit of clarification, whether it was about the deluge option. But in terms of deluge, it's just going to run across the whole site. In terms of the rainfall, that's going to land across all the subcatchments, and the runoff's going to be generated from each subcatchment.
yeah, and that's part of what the like analysis criteria, where you go in here and set that stuff up. Okay, well, the next thing that I'm going to do is start to build out my system. I'm going to add in this bioretention. Well, actually, first I need to turn on my proposed condition or proposed development to make sure I'm not running into any buildings or anything like that. But I'm going to put the bioretention cell up here, and then I'm just going to kind of draw something in that's going to fit in between all these buildings. And then within the rain garden itself, some of these things are going to come pre-populated based on the template. Other things like the exceedance level and base level are going to be set based on that surface and the information associated there. I know that I want to increase my depth to 2.2, and I'll explain that in a little bit, but I also need to set a Mannings in here, so 1. But this 2.2, my filtration layers, I know my under drain is about 6 inches, so I want to make sure in my course fill that it has enough space, so I'm just going to increase that to 8. I know that my filter material is 50 inches per hour, and my course material is 200. I also know this is a custom soil type, so I'm going to specify the field capacity and the wilting capacity to it too. So from there, that's all we need to do there for right now. Next, I'm going to add in my dry pond down at the bottom. And for right now, I'm going to, again, just kind of make a guess on how big I need this. And if we go and click on the attribute data, you can see that it defaults to just a triangle right there. And if we were to use the sizing calculator and this side slope, we can specify the side slope. So foot per foot, 0.5 is representative of a 2-to-1 slope, and we can maintain the top area that I drew, and it's going to automatically fill in that bottom area and update the look there too. So I'm going to hit OK there. Once I do that too, you'll notice that there's a dotted line now representing the bottom of my pond as well. So again, some of those true to, how did you describe it? True to size value or something?
Yeah, true to site.
True to site, there you go. So yeah, there we go. From there, I'm going to start adding in my pipes and connecting everything up together. My junctions, I'm going to use some standard boxes, one right about there, and then one right about there, just so I avoid any kind of conflicts with my buildings and things like that. My connections through everything, I'm going to use these standard pipes. I'm going to come from my rain garden and go to my manhole. If you click it, within the area of the BMP or something like that, it's going to automatically associate that with the rain garden and know that that's going to be an outlet for it. I'm going to go and connect the rest of my system here and then empty into my dry pond, and it's going to know that that's now an inlet for it. I'm also going to use a trapezoidal channel within the rain garden to connect into the first manhole as my overflow weir. There's a couple things, again, these are templates, so a lot of this stuff comes either pre-populated by the surface or specifications we've already given it. Manning's in is not one of those, so I'm going to add in an appropriate value for the for like short grass. And then also within the rain garden itself, I need to specify that the trapezoidal channel isn't part of the underdrain. It is going to be a weir type outlet. There is a width calculator for trying to understand how big your weir maybe needs to be. I'm just going to put a guess in of 1 foot for right now, and those other parameters look good to me too. The last thing that we need to do before sizing our pipes is to name our flow paths, so we can specify which line I want to size in my little calculator that I'll show you in a second. So I'm going to do one for my main line, and then I'm also going to do one that starts with my bypass flow, just so we have everything in there, and rename this bypass. So we're going to start off by sizing really just sizing the pipes throughout there. And the way that we do that is using this little design wizard. I'm going to go ahead and lock my trapezoidal weir because I don't want anything to change with that. But if we go through next, we specify the return period that we're trying to meet, and we're going to size to the 10-year. And we're also going to not lock anything, so it's going to be able to change level inverts to maintain a minimum cover depth, as well as fit within some parameters of slopes. You can also check velocities and some other things like that too. So once we hit next, it's going to give us a summary of the changes that happen throughout the system. There's some warnings here for maximum slope exceeded, but these really aren't very steep, so I'm not too terribly concerned about it, as well as those elevations. So once I hit finish, it's going to update all that information and then provide me with some results of how exactly it was deciding some of those parameters. If we pull up the profile, you'll see that, one, we've got some problems with our manholes not meeting the bottom here. And then also, I can see that my downstream invert of this pipe is a little bit below my baseline of my dry pond. So I'm just going to double click on that and then change it so that it is matching. Oops, 2.6. And same thing with my bioretention cell up here. My base level is 18.545, but I know I have 2.2 feet of depth to my underdrain, and I want my pipe leading out here. That's going to be connected to it, so I need to set it at 1852.3. I'm going to hit OK there. And then we're going to go back through this design wizard really quick. But this time I am going to lock those slopes in invert, so it's not going to change that, but it still has the ability to change the size of the pipe. So since those slopes changed a little bit, I just want to make sure my capacity is all right. You can see there's no changes made, so all the pipes stayed the same size there. From there, and the last thing, since the manholes, we have this nice synchronized manholes with the inverts. So if I hit that, you can see that the two manholes are now synchronized. And if we look at the profile now, those all match up with the bottom, the inverts of those pipes now. So the last thing that we really need to do before going in and before running our analysis and everything like that is within the dry pond and the outlets associated with it. So we need some kind of definition for a control structure that's inside of it. There's many different kinds that you can do, and you can add multiples at a time if you want. I'm actually going to pick the multiple outlet type, so it's basically going to build for us a depth of discharge curve. So if I edit the table here, I'm going to add in an orifice for my low flow and a weir for my high flow. And within here, there's these nice little calculators for getting an idea of what these diameters should be. So I know my pond is 5 feet, so I'm going to design it to be 4 foot depth. If we remember from our existing conditions, we had a design flow that we needed to meet of roughly 1.8 CFS, and then my coefficient of discharge seems appropriate. So that's going to give me about 6 inches of diameter. And if we hit OK, it's going to populate that for us. This is going to be sitting on the bottom, so our depth above the invert is 0. With the weir, I'm also going to go into the design calculator so that we have 6 inches of freeboard. I'm going to say half a foot of design depth. If we remember, our 100-year flow event was like 3.4 in the existing conditions. I'm just going to estimate 5 since that's roughly double. And then again, my coefficient of discharge seems appropriate too. Depth above the invert is going to be 4 feet since our low flow orifice is taking care of everything, since that was the design depth for that. And then I hit OK. That's going to populate this table for me so that it adds all that stuff in.
Before you leave the pond form,
Yep.
Brian? Didn't quite catch you.
Okay.
That's okay. There was a question about groundwater being incorporated into the design of the pond. So I thought it was maybe just worth pointing out the initial depth option on that screen there where you are now.
Yeah.
And essentially any sizing calculator is going to work above that initial depth option.
Okay. Yeah, so that's that. And I was looking for, oh yeah. And there is an infiltration rate that you can specify too. That was already pre-populated with the information there, or the information in the template. Just thought that was worth that, kind of along the same lines there. So at this point, I'm actually going to reroute this catchment to this manhole down here, since that's more appropriate. And then we're ready to go at this point. I'm going to validate things and see if everything is okay. So it doesn't look like it. I've got a pipe that doesn't quite match up. So that was because I tweaked those numbers a little bit, and since the rounding, I didn't see these like significant digits. It's not a big deal, so I'm gonna keep with that. And then this one is basically telling me that there used to be a inflow to the rain garden. That was that bottom catchment that I redirected. And so it makes these suggestions for what you should change it to, and it's as simple as clicking it right there and pressing apply, and now we're okay. So we're good to go now, and we can run this and see what our results end up being. So I'll go ahead and run that. And just about done. There we go. And it's going to give me some results. You can change the different storm events down there, but there are also some different results that you can pull out as far as summary information and profiles. There is also this comparison report where you can pull out different information comparing the existing to the developed, look at these different events that we've run, as well as tabular results as far as inflows and outflows, as well as graph results. So if I update the preview, we can see what we're going to get there. And we can see that our existing site is about that we're not meeting our discharge requirements for our developed site. So we're going to have to go in and reevaluate and expand that that dry pond. But these reports and these headers are fully customizable to be able to make them whatever you want. You can also change this logo out to be your own if you're a consulting firm or a municipality or something like that and want to use their own symbol up there. You can do that fairly quickly. Also from there, there are many different export options as far as exporting out things to CAD, so you can export the whole pipe network and all these features into a plan view, along with it comes with labels and things like that, so you don't have to copy data from your model into CAD. It all comes out in that export. There's also land XMLs that you can use within your pipe alignments and things like that within CAD. And then also if we pull up the profile, we can certainly view results and different things like that through here. I'm going to change it to the 10-year storm because that's a little more interesting, where you can evaluate the HDL going through your system and the max elevations that you get. There's also some different warnings and things like that that you get for maybe surcharging or overflows or things like that. So you can go through and check that pretty easily. There's also an export option to CAD for the profile view as well. And again, it comes out in basically a gridded format, longitudinal, very similar to what we're seeing here, just in CAD format, along with a lot of these numbers and things like that for labeling the different features. And I really think it's just as simple as exporting it out, putting a block on it for your plan set, and calling it a day there. There's also some options for exporting out to image or GIS, depending on what other kinds of stakeholders and things like that you might have looking at your system. So that's roughly it. I can maybe resize this as we're maybe looking through some of those different questions and things like that to see if I can get it to work. But as you see, as I change numbers and things like that, and then update my bottom area as well, and I hit OK, it's gonna update the size of my pond down there as well. So I can, again, that size the site, I forgot the phrase again, but oh well. But having a good picture of what exactly you're going to be building is certainly
true to site, I like to say.
True to say.
Being able to see exactly where stuff connects in, actually in the right location, not an approximation. There were a couple of questions, actually, a couple of similar ones. One on exporting pipe networks. So I think you mentioned that on the export menu, there there is the option to export the pipe network to land XML, to GIS, to CSV.
Yeah, and
And
I'll
sorry,
admit no, well, I was just saying I'm pretty sure that XML. Um, do you know what's in the XML? I mean, it's mostly like I forgot what the tab is or the window is, but bringing those basically into pipe alignment
yeah, so with
information.
the land XML export, that's going to have the pipes and manholes. But there was also a question about Civil3D more specifically, and actually we haven't gone into that today, but there's an integration with Civil3D that allows you to create an InfoDrainage network from a Civil3D pipe network and use their parts mapping to map from a Civil3D pipe network into InfoDrainage, and then actually go back the other way and update a Civil3D network from an InfoDrainage file as well. And that has round tripping capabilities, so everything is tagged, which means if you do have to adopt those design iterations and go through that process multiple times, then that's possible.
Yeah, yeah. And that can be a big advantage for sure, too, as you're, having to manipulate the design and stuff like that. I did just make a guess at what I need to size in, and I do meet those requirements now. So that's great. We did have a question about resizing the pond really quickly, and it also kind of parlays into another question about storage and optimizing the same. Depending on what exactly you're trying to accomplish, could be like a runoff reduction, but I'm going to use the there was one for like meeting flows or something like that.
Yeah,
But there are
the
some tools in here to be able to give you an estimate on. Go ahead,
yeah,
Jess.
that's okay. The quick storage estimate option allows you to actually put in, so say the design flow that you're
Oh,
aiming
that's what I'm
for.
looking for. Yeah.
Yeah, so the discharge rate.
So I can, yeah.
And if you have infiltration, you can put that in as well, and or the calculate option with either user input as you have now, you can enter the area and so on, or with the plan
Yeah.
data option, it'll read the
Yeah.
catchment.
I'm going to run through this because with the plan data, it says that I've only got about 2 acres, but it's only seeing the lower
That's
catchment.
connected to the
So
pond.
I'm gonna just change it so that it's a 6.5.
Yeah.
Keep my discharge rate the same, and looking at that Greenville storm.
I think you just missed the
Oh,
calculate
calculate.
option.
Whoops.
Yeah.
There we go. So it's gonna give me an estimate of what my storage volume needs to be, and if I hit OK, it's just gonna give me the average, the right in the middle point. And if I hit OK again, it's going to automatically update my volumes and things like that. And so I've now changed that, and you'll see in the plan view once I hit OK that will just automatically push that out so that it's again true to site. I got it there. um, so the last thing that I did want to show that was pretty quick. So this is InfoWorks ICM, and we did mention some new integration that we've built in. This is a different model simply because I have a larger model, so it made more sense to import this different model into here. But this is a system in ICM, and we have now an import routine to bring in an InfoDrainage file. So I've got the one right there. If I hit open, it's going to tell me everything that got brought in from that file. and you can now see that we have our new system. So I guess I imagine a workflow where a city might be using InfoWorks ICM for their watershed planning model, and then they have developers using InfoDrainage and submitting the drainage file as a submittal, and then the city can just import that into their model, make a few tweaks as far as, you know, cleaning up some catchments that maybe change due to grading, and then also maybe connect it into the overall network. And then they can, one, have a model that's like constantly being updated based on new developments that are coming in, and being able to run it and see what impacts things have on the system as an overall system. This one just drains out to an outfall in that stream down there, but you can see, like for instance, our pond comes in and along with our storage array and everything like that. So something else worth mentioning, but pretty short there. So I think we got, looks like we just got a question coming in. How about the runoff generated from the pond itself? Does the model account for it? Might need a little more clarification on.
If that's in relation to the water landing on the pond itself, then you would need to draw that as one of your contributing areas or have it included in the catchment runoff if you want that included. But there's no issue with having overlapping catchment areas and stormwater controls. So yeah, but it doesn't automatically assume that that's included, so you would need to draw that.
Yeah, so like pretty similar to how the rain garden's set up here. One thing I forgot to mention that is worth mentioning, it's not included in this one, but there are some options for adding in pollution. So you can add in pollutants if you'd like, and I'm just going to do TSS as an example. If we go into the pollution here, you can see our different layers that we have associated with our bioretention cell, and then we can specify either percentage removal or a first order decay, maybe if you're doing nitrification processes or something like that, and want to model it like that, you can do that. But then you can get an idea of how well your BMPs are performing and how much you're really able to reduce and how much is going out through the overland flow weir or something like that. So
Ryan, if you just switch to the inlets tab on that, there was another question about the rain garden. So it's set up currently with no restriction on the inlet, but if you click on the capacity type drop down, there are a few options there to restrict the inlet. So you can go for like full HEC 22 sized inlets, or I guess a slightly simpler approach with high and low bypass or rated by flow. What that means is that any flow that isn't captured by that inlet is a bypass flow, and that can be either lost or connected to another connection. So there could be another trapezoidal channel, for example, that takes the bypass flow around the rain garden and downstream to prevent washout by scour.
yeah, and these are some of my favorites just because of the visuals and things that go on with it, but I can, just as an example, just make up some numbers really quick. But this is like a little calculator to be able to get a better understanding on what exactly, so all the specifications that you would need if you were to actually like go into HEC 22 and do everything. Great length, I'll do 5, 5, or that's not really appropriate. But you can see these nice visuals to be able to see what your spread's going to be, depending on what storm you're looking at and all that kind of stuff. So I like it a lot. It's really neat to me. So just to get a better framework on everything. So I think that covers a lot. I guess, is there anything else you wanted to mention while people are maybe thinking of some questions and other things like that?
I don't think so. I think you've done a great job of showing how you can go from pretty much nothing to
To a nice
having
set
a
of plans.
design. Yeah.
For sure. So, there are 3D views and things like that, so you can, whoops, get like a better.
Yeah, you might want to go extents on the plan. There we go.
So you can, get like another kind of visual on things. This is, but we can see our bioretention up here at the front and our pond there at the bottom. And that trapezoidal weir and just the shape of it and things like that, but just something else. So I think that's about it. I know we're a little bit short on our time. We got about 7 minutes, but I'll, since nobody has any more questions and we kind of covered everything we wanted to, I'll cut it short. But thanks a lot, Jess, for joining me and being able to present, and hopefully everyone found it really informative and all that. So
Thanks, Ryan. Thanks everyone for joining.
Yeah, and we'll see you next time.